let us look at problem number 3. I am not going to completely solve, but let us first draw the free body. Once we draw the free body diagram, it is a matter of writing down the equations to solve it, or equations of equilibrium to solve it. So, let us do that. Now, I have point A here on the rod, point B here. Okay. So, they are connected like this. In turn, this is connected like this. This is the frame of that. The 900 Newton is acting on this, right. Let us say this distances here and here are 75 and 75. This is 300. Okay. This to this is 225. It is better to draw these dimensions in the free body, so that you are ready to write down the equations of equilibrium directly. Okay. Any mistakes also will show up easily, because you are representing these dimensions good enough for drawing the free being able to write the equilibrium equations. Okay. Now, we have already represented 900 newtons. There may be some weight to this, let us say that is negligible. The other 2 points of contact will have an interaction. So, let us look at the interaction. The vertical bar does not allow it to move in the horizontal direction. Let me use another piece of another color. Okay. So, let us say this is AX. Since this is 3 dimensional, let me just now draw the axis. This is x axis, this is y axis, and this is z axis, let us say. It always helps to draw this, and therefore, I will draw along this x direction AX, which prevents the movement in the x axis. Similarly, along the z axis, it prevents movement, which means AZ. In a similar way, at B, I will have, I am sorry, I will have a restraint along the x direction and the restraint along the z direction. So, let us call this as Bx and Bz. If there is some friction on this, we will also have along the y direction Ay and By. Okay. If it is very free to move up and down, there is frictionless surface on this, then Ay and By will be 0. Okay. Now, having done this, we are now ready to write the equations of equilibrium to solve for all these forces that we have. Okay. There are 6 equations that we can write, and we will be able to solve this problem.